Okay, so this video is really encompassing everything we've done with probability, two-way tables, and really starting to focus on this concept of independent events. So we have this scenario here where cars are created at two factories, and the cars can either be rated highly or not highly. Um, So the first part says create a thousand two-way hypothetical 1,000 two-way table. That's already actually been filled in for you based on these percentages at the top, where we have 60%, so 600 out of 1,000, 70%, so 700 out of 1,000, and 10%, which would be 100 out of 1,000. Um, Sometimes the idea of making your own table can be beneficial in terms of figuring out these independence ideas as well. So we'll keep that in mind and maybe use that as an example later on. So the first part of this question is, if you were an individual buying a car from this company, do you care which factory the car came from? And if so, which factory would you choose and why? Uh, if you want to pause the video at this moment, kind of look at the table, determine what you feel like uh, would be the best option, go ahead and do that. Otherwise, I'm going to go ahead and start this. Um, so there's a couple of approaches here. We have that um, for factory A, 400 out of 600 are highly rated. So that's actually a conditional probability. So if I designate these with letters, I call this A and this B and this H for highly rated and not H. We use that squiggle symbol as not H. So the probability that a car is highly rated, given that it's made of factory A, is 400 out of 600, which if we reduce that is 2/3 or 66.6 repeating percent. Versus a car that's at factory B, probability that a car is highly rated given that it was made at factory B. Well, there's fewer cars that are highly rated, but it's also fewer cars in general that were made at factory B. So this one's actually 300 out of 400, which is 3/4 or 75%. And so to me, it would appear that it is better to have a car made at factory B. So then part C is the rating of a car independent from the factory it is selected from. So we have a couple of ways that we can prove this. One we've actually already talked about, which was using the joint probabilities. But we're actually going to focus on this. It's based off your answer to part B. If these events were truly independent, it should not matter which factory it was made at. The fact that you were able to determine what you wanted for part B is what's leading us to say that these are not independent. So we have to prove this mathematically. So this is going to lead us to one of the definitions of independence. A new one we're going to talk about today is the probability of, and this is just going to be a generic formula right now, probability of A given B, and this has nothing to do with the A and the B at the top there for now. Probability of A given B should equal probability of A if independent. So for hours, we are going to use the probability of H given B and see, does that equal the probability of H? So essentially we're asking, does applying the condition of being made at factory B affect whether a car is highly rated? And we already know that the answer is yes, it does. So let's use numbers. So the probability of H given B, we already calculated that. That was 3/4. Probability of H, well, the probability a car is highly rated, well, that's 700 out of 1,000, or 70%, or 7/10. Those two fractions are clearly not equal. When I'm talking about independence, I want them to be exact. At least in our Algebra 2 class, we want them to be exact. They can be close in an AP Stats class, but even when we talk about close, they have to be close within the 10,000th. So for our class, we're going to say that these two things need to be exact. So since these are clearly not equal, we can say that the events are not independent because probability of H given B does not equal the probability of H. Now I designated what H and B were, which helped prove this. Some of you might be asking, well, why did I use H and B? Why didn't I use H and A? And the truth is I could use those. We could be asking or answering this question by using the probability that a car is highly rated and made at factory A. And so let's do that. And I'm going to change the color up here. So another option could be, well, let's compare the probability that a car is highly rated given that it's made at factory A. Again, we're questioning, does the condition affect that probability? So if I remove the condition, are those the same? Well, we already know, we calculated both of these now at this point. So probability that a car was highly rated given that it was made at factory A was 2/3. And the probability that the car was highly rated with no regard for the condition is 7/10. And again, those two fractions are not equal. So I could write a very similar sentence. The events are not independent because the probability of H given A does not equal the probability of H. The big picture with this, improving independence, is the math and the sentence. You cannot prove that two events are independent without a sentence. All right, I'm going to kind of stop this video here and then just work through some examples in a separate video since this one's already 8 minutes long. All right.